Hello, thank you for being patient. We had some technical issues. AI, I guess, has not reached that point yet to solve all our problems. So thank you for having me here, and it's a pleasure to see so many faces in this room, anticipating for what we are going to talk about. My name is Lazaros Polacos, as it was mentioned, and I'm the AMIA AI Leader for consulting for EY. And I also run the AI Center of Excellence that we have here in Athens, where we are serving all our European, Middle Eastern, and global clients. What is my topic today? I think you hear it often. I think there is also another panel that is happening later at 3:30. It's about transforming our lives and our daily work lives in particular. So I'm going to make a very brief introduction to AI just so that we are on the same page. I know since you are here, you know AI in and out, I'll try to be brief on that. And then I'll tell you how we are thinking of transforming our daily life with AI agents, okay? So here is something to think about. AI has come of age in some sense, and it is ready to be part of everything that we do, either in our daily or our work life. Just to show you how it has evolved through the years, and as I said, many of you may know it already. It started back in the 50s when some intelligent people, some intelligent scientists thought that since computers were becoming bigger, faster, and they were being used for various tasks, at some point they could emulate human capabilities, human intelligence. It took many years and many, how should I put it, winters and summers in this effort, because many attempts were made. At some point they thought that they had cracked it, and then it failed miserably, and they went back to the drawing board. But we had at least, let's say, three areas of success so far, 3 periods of success. The big one, the first and big one, which still continues today, has been machine learning, where we learn again from data, but the human has to extract manually or semi-manually the features, that is, the characteristics of the data that are important for the thing that we are modeling, and then we try to learn the parameters of a model, a mathematical model that has been built specifically for this purpose, typically various mixtures of Gaussians or other. So this has been quite successful. It still continues, and if you are flying on an airplane, remember that it's it's the co-pilot, whatever you want to call it, the pilot, the automatic pilot is probably a machine learning system. Now, since 2000, let's say roughly, we have a new era in AI, which starts with deep learning, and here we have 3 or 4 big things that happened that changed, let's say, the way that we were addressing AI. The first one was that we had a lot of computing power, more computing power, and cheaper memory and cheap computing power. The second thing that we had is lots of data that were relatively free, and they were on the web. And the third thing that we had was we had free code based on various things like the GitHub and things of that nature. And the fourth thing that we had was, let's say, a major advancement in our understanding of neural network technologies. What happened was that they proved that particular ways of building neural networks, which were long, short-term memory networks and other recurrent memory networks, that were capable of emulating any system. So given data, I have this system, I can emulate any other system, I can bring out any answer. So with these advances, both theoretical and technical as we have, we enter the era of deep learning, where now we don't need to manually extract from data the characteristics, let's say features, but we go directly from data, train a system that can learn, a big system, and then it does the job for us. And these are systems that are trained for purpose. For example, the system that recognizes your face on your cell phone, okay? This is trained for purpose. It is an AI system. It learns to recognize faces. So it has a specific task. And relatively recently, we had a big hype with the generative AI technologies that came about. These technologies have been around, at least in theory, since 2014, but they became very prominent when the first version of ChatGPT came about and various other models for images and so on. What is the major difference that happened now in this new era? We are not training for purpose. We are training these systems so that they generate content, be it an image, text, other things. And the idea is we evaluate them for how good they produce this content for different tasks. So for translation, how well does it produce for this task? For story generation, how well does it produce for this task? For summarization. So we have systems that are trained differently now. They are trained with many tasks, and they're evaluated for the content that they are generating. That's why they are called generative AI systems. And you can see the evolution, for example, for images, which is pictures tells 1,000 words, how fast this has been progressing and how photorealistic the results are, and how much more in context, understanding what the user requires. So this was a prompt that says, draw an old lady drinking coffee at a French cafe, and you see the evolution of this thing. Actually, I want to show this very briefly. I'm not going to go through this. This is just a chart. It changes every month, every week, and so on, of the evolution of the large language models through the years. And it comes all the way to October 24. And you see there are major announcements from major players practically every month. The thing is that this space is huge right now. It is unmanageable to track this change anymore, okay? And there are various efforts there, both commercial that are happening and also open source, okay? And the third effort is to make these things smaller. So based on this and the fact that there is this huge space where there is big investment and also systems with major capabilities, you can imagine that across the use cases of an organization, whether it is on risk and compliance and legal, whether it is on technology, on servicing, on HR, on finance, or customer and growth, you are going to have applications that are going to be transformed with AI, okay? So this is the part that talks basically about use cases for the different parts of an organization that are going to transform, let's say, some of the things that are happening with the use of AI. And the idea is that we have already been doing that at EY for several years. We started this journey not yesterday. It is actually more than 4 years that we have been on this journey. And it's before, let's say, this whole hype happened about AI. And there are various lessons learned if you want to transform your organization using AI. The first one is that it has to come from the top. It cannot be at the bottom, let's say, an IT manager that tries to do something with AI. Because AI, as I'm going to say in a little bit, transforms the way you work. So it cannot be that I'm going to do this little use case here. The value will not happen because from 20 minutes I do it in 7 minutes, okay? That's not where the real value is. So executives have to be engaged. There has to be a will to change things, and there has to be from the top, and it is an engagement that should not go back because of a few setbacks, because these are new technologies and setbacks are going to be there. The second thing is to plant the flag. In each organization, there has to be a marketplace of these kinds of solutions, so that people can go, can explore them, can use them, can get acquainted with them, can become experts on them. The third one comes with the mandatory mastery. People have to be trained and be retrained either to be users of this technology or the experts that will build these technologies for organizations, okay? Or know the landscape at least. And then you have to be a disruptor. Don't think, again, as I said, only about how I can implement a little use case here that can do something with AI. You have to be able to disrupt your operations, to imagine them in a new way, and to even self-cannibalize them. Here I'm probably quoting, or let's say getting inspiration from what Steve Jobs had said when they introduced the iPad mini, when they had the iPad, okay? What did they say? What did he say? Many people accused him that he was cannibalizing the market. And he said, if I cannot cannibalize my own market, then somebody else will do it for me. So you also have to see what your business is, how AI is going to be transforming it, and maybe cannibalize part of the business or transform it, because it's going to happen even from your competitors. The other thing that you need to do is to learn by doing. You have to walk the talk and walk the walk and talk the talk, as they say, with your functions and how you are using them. And finally, you have to flip the execution path. As I said, you have to transform things versus just some use cases. And I'll jump exactly to that transformation because we wasted some time in the beginning with the technical issues. So let me say here that there are 5 ways, at least that we conceive so far, of how humans and AI systems are going to be collaborating. On one hand, you have AI systems that operate by themselves, okay? So for example, the automatic braking system in your car, okay? It does something, you don't know it, it has practically no interaction with you, okay? And it does something when it's needed, okay? Then we have the other far end of things where AI is sort of like a partner. You talk to it, you exchange ideas, and so on and so forth, okay? And there, it's the other extreme. You have a lot of interaction, but the AI doesn't do much, right? And then you have a lot of things that are in the middle where you have, let's say, collaboration between humans and AI, where either AI takes a task in parallel, gives you the results, and then you go for it, or you collaborate to co-generate something, or let's say it acts as a colleague even, okay? And basically, this is the space where a lot of systems are going to be coming out soon, because, the ones that don't need human interaction, okay, we don't need, the everyday person or at your work, you don't need to know them. The other one, all right, it is sort of a far-fetched, not far-fetched, futuristic scenario where you have somebody to be talking about and so on. The idea is that you can imagine AI and GenAI as having a lot of building blocks, okay? When you go to an LLM and you interact with it, with ChatGPT and so on, for example, what do you ask it? You ask for summarization, you ask to write a document, to search, to give you an answer, to write code and things. These are all different capabilities, different skills, okay? And you can have even subsystems that combine these skills to do something. The idea is to take the whole, let's say, life of somebody, the whole task of somebody that is doing at work, break it down to these different steps and see how these different AI capabilities apply to each step. Which ones do you need to provide in order to transform that step in the process? And then see the end-to-end result, how you are going to achieve it by interjecting at each step of the way of a process the AI capabilities, all right? So here I've taken a trivial example, which is how I created the presentation today, let's say. I did some question answering on my previous presentations to find content that is relevant. I classified it. I also saw some images and I converted them to text so that I can search them and so on. I did document comparison. Is this a better slide than that? And so on. Then I also searched by my emails, my invitations, and so on to see what material I should be presenting in this event and what was relevant. And then I talked to my team also, I got their input, and then I created a first deck. And then I started the creative process of creating new art, new images, new content. The text creation, the tone of voice, and so on were all part of what the AI can do. And then at the end, I compile the presentation, I make a video, I have text-to-speech, I translate it to other languages, I summarize it, and I send it out, okay? So this whole process, all these different pieces have AI components or even non-AI components that I need to interact with in order to do my work. And here it brings me to the point of what I want to cover, is that we have agentic systems. It has been talked also, I heard the previous gentleman also refer to this. Agentic systems are the ones that are basically digital workers, and they're going to be working side by side, let's say, with us to complete a piece of work. What is the idea? The difference between agents and other things is that these systems now are not just a chatbot, just the LLM, but they have a planner that knows the business process. It has various tools that it can use, and it has a memory where it stores the results, the intermediate results, so as to either pass them to other tools or to use them for a presentation or other things that the user wants to do. So, and here's the difference, as I said, with the chatbots. The chatbots are only a modality to interact with the LLM, whereas here we are talking about a true assistive system that helps you complete a task end to end. It has memory, and it has the business logic to be able to carry it out. So, in essence, these multi-agent systems are going to be looking something like this, and I say are going to be looking because probably you haven't deployed one right now, but we are deploying these things. We are building these things for clients around the world, and they are becoming, let's say, what is expected to be the next generation of systems. So here you have various skills or tools that can create code, that can do retrieval, that can access the web, that can collect documents, and then you have different agents that can do different specific things, like a company analysis, a report assistant to generate reports, or a sentiment analysis, and you have an orchestrator assistant that decides based on the user input what things to use and how to present the results and what results to keep and pass to other agents. And here I have one system to show to you, because I promised that this will be, and this is my final, let's say, part, which shows you a company analytics agent. What is the idea? To analyze data from the web and see how good or bad the company is. Okay, here we have taken Dell, but it doesn't matter. It is fictitious data anyway, okay? So that we are not really evaluating. This was done with our own business people, and is a complete end-to-end system to do this. It reads documents, it finds information, it writes code to evaluate things, and then it spits out reports. So without any further ado, let me start.
Hello. This is EY's Company Analytics Agent. It's your valuable companion in several financial analysis tasks, such as valuating a company, comparing it with its main competitors, analyzing the macroeconomic environment, and summarizing the public sentiment as based on news. All this magic happens automatically, with little to no input from the user, by leveraging generative AI technology in a user-friendly application. So let's start and explore together some of these functionalities. The agent employs knowledge about valuation frameworks based on the Handbook on Valuation, which is uploaded in its knowledge base. The user can ask the agent to inform them about the various DCF-based valuation frameworks. As we can see, apart from the valuation frameworks, the agent also provides some suggestions on how to efficiently apply them. Indeed, as we can see in the book, the agent has extracted this knowledge from a table called Frameworks for DCF-based Valuation. This table includes all the available models along with their assessments. Moving forward, we choose to apply one of these frameworks specifically for Dell. Initially, the system outlines a detailed, step-by-step strategy to approach this query. Subsequently, it retrieves Dell's financial data through the designated tool, ensuring the process's progress is transparently communicated.
So this is one of the things to notice. You see here, because there is the business logic behind it, it can tell you how it's going to execute it and what tools it's going to use, okay? So this is very important also to address the explainability of such systems. Typically, when you ask, let's say, just the LLM, you don't know how it got the answer, what it is, and so on. Here, because you have the reference, let's say, to how this is going to be done, you have this access. Also here it is shown, because we stopped the speaking of the thing, how it got the formulas, how it understood them, it extracted the value, and it also is going to tell you what values it is missing in order to complete the task. And then it is going to generate code in order to compute these things. Let's put it up back.
We see that the agent communicates in real time its thought process and the calculations performed. While the process of evaluating a company can be laborious for an analyst, requiring a lot of calculations and financial modeling, we can see that generative AI technology can easily compete the human analysis by requiring minimum guidance by an expert. The user can prompt the agent to extract the analysis up to this stage of the conversation in a thorough, comprehensive report whenever this seems suitable. By doing so, we ensure that all the necessary information will be exported in the report without missing any details. The agent is also capable of associating external factors, such as macroeconomic indicators and news sentiment, to the analysis of a company's financial status. It can retrieve macroeconomic data and analyze their impact on a company. The macroeconomic environment can help the analyst further understand the financial status of a company and assess its growth more closely. The inclusion of macroeconomic indicators in the evaluation of a company's financial status provides financial analysts with a broader context in which to assess potential risks and opportunities. Indicators such as GDP growth rates, inflation figures, and interest rates can signal the overall health of the economy, which in turn affects consumer spending, business investment, and corporate profitability. In order to deliver comprehensive and up-to-date insights, we ensure that the report is consistently augmented with the latest information generated throughout the conversation. This methodical approach to report development not only enhances the granularity and discovering breakthrough technologies.
Passed anyway, but just to complete this by describing it, another part that we do is after you collect this information, you want to do reasoning in this information. That is, apply a methodology of thinking about it in order to, let's say, get to results. This can be also part of the process that you have described in your business logic, so that the LLM can help you do what it is called reasoning, or let's say step-by-step reasoning, where you give it what it needs to be, a sequence of instructions about what it needs to consider in order to produce a result. And so it can do these things both with numbers and with text, and at the end, just to show you that you generate you generate a report that contains the results of this analysis, as well as you can edit it, and also all the charts and all these things. So let me go there, and you can see that because AI has generative capabilities, it can produce the report, it can produce it and populate it in a particular format and in a particular template, and it can also create the graphs that you want with other tools that it will call in order to make them. So that's all I wanted to show you today, and trigger a little bit your thought, but also start thinking about, in all your organizations where you are, how you are going to transform your processes end to end, not about singular use cases and singular systems that are AI. Thank you very much for your patience and for your time.